Hi, so for the extra credit problem, I chose a problem from chapter 4, which is problem number 12, and we need to find the eigenvalues and the eigenvectors for this matrix. To start, we first need to write this matrix in the following way. Okay, so now we need to get the determinant of this matrix. To do that, I like to do a little trick, which is simply by doing the following. We are going to start with the first column and we are going to pick the first value. So then we are going to cross all the rows and columns in which this value appears, and we are going to use this little 2 by 2 matrix to get the determinant. So 1 minus t, we first pick the first value, and now we are going to get the determinant of these 4 values. So it's going to be 2 minus t times 1 minus t minus negative 1 times 0. We are going to repeat the same process as we alternate the signs in each column. So now our following value is going to be 1, and we are going to be left with these 4 values. So it's 0 times 1 minus t minus 0 times negative 1. Okay, the last value is going to be negative 1. We cross columns and rows, and we're going to be left with these 4 numbers. So it's going to be 0 times 2 minus t times 0. So the next step is to solve for this equation. And first we are going to multiply these 2 numbers minus these 2 numbers. That's going to be okay, so now these 2 numbers, and since this is a 0, we are going to eliminate this. We are going to eliminate this, and this as well. So this becomes 0, 2. Now we are only left with this equation. And we have to multiply it. 1 times this equation is just this equation. And negative t times these equations gives us the following. Negative 2t plus 2t squared plus t squared plus, minus t cubed. So we just need to simplify this equation, and we are going to get negative t cubed plus 4t squared minus 5t plus 2. Okay. We now have the polynomial equation, which is this one. So now we need to find a way to factorize all of this equation. So I'm going to use synthetic division. So I'm going to pick the coefficients of each individual value that we have in this equation. So we have negative 1, 4, negative 5, and 2. And now we need to find the common factors of 2. And we know that is 1 and 2. And it can be either positive or negative. I'm going to start with a positive 1, and I'm going to use the synthetic division. So I'm going to first get this negative 1 down. I'm going to multiply negative 1 times 1, negative 1, 4, minus 1, 3 times 1, 3, negative 5 plus 3 is going to be negative 2 times 1, negative 2 plus 2 is 0. So we got lucky, and we have that negative 1 is contained in this equation. So we are going to change the sign, and we are going to use t minus 1. And now we are going to use these values that we were left with. So instead of starting with t cubed, we are going to start with t squared, and it's going to be negative t squared plus 3t minus 2. And now we need to factorize this equation, which is more easier. So I like to get rid of this negative, t squared minus 3t plus 2. And so we need a number, two numbers that multiplying gives us a 2, and added or subtracted gives us a negative 3. So that would be a 2 and a 1, negative, negative. And we just now need to put this t minus 1 here as well, t minus 1. So if we see these two values are equal, so it's going to be t minus 1 squared, because they're multiplying, times t minus 2. And this would be our eigenvalues. It would be 1 and it would be 2. Okay, so now we want to get the eigenvectors. So we are going to start with our first eigenvalue, which is 1. And we need to use the following formula to write our matrix again. So as we can see, this matrix is already in the reduced row echelon form. So now we need to get the two equations from this matrix, which is going to be x2 minus x3 is equal to 0, and x2 minus x3 is equal to 0. So we have that x2 is equal to x3, and x2 is equal to x3. So to get our vector, we will write it in the following form. For x1, we don't have a value. So for x2, we have x3, and for x3, we have, x3 as well. But we also need to show that x1 is contained, so we are going to put x1 in another vector, but that does not contain x2 or x3. So we will end up with the following two eigenvectors. For the last eigenvector, we are going to use the eigenvalue which is equal to 2. We are going to repeat the process and write the matrix in the following form by subtracting the eigenvalue. So we are left with this matrix. And as we can see, this matrix is in the reduced row echelon form as well. And we only need to write our equation. So it's going to be negative x1 plus x2 minus x3 equals to 0, minus x3 equals to 0, and minus x3 equals to 0. So to get our vector, we need to write it in the following form. And we have that for x1, we have this equation, which is going to be x1 equals to x2 minus x3. Since we know that minus x3 is equal to 0, x1 is going to be equal to x2. x2 is going to be equal to x2, and x3 is going to be equal to 0. So we will be left with this eigenvector. Finally, we would like to know if this matrix is defective or not. So let's try to think about what the values we have right now. We have two eigenvalues, A1 and A2. We have an algebraic multiplicity of 2 for the eigenvalue 1 and an algebraic multiplicity of 1 for the eigenvalue 2. And for the geometric multiplicity, we have A2 because we found two vectors for the first eigenvalue, and a geometric multiplicity of 1 for the second value of the eigenvalues. So since these two numbers are equal, this matrix is not defective.